We usually find the crystallite size using XRD analysis, using XRD graph, and we find the grain size from high resolution transmission electron microscopy. These two techniques are basically use the same approach, that is basically the scattering phenomena, and it is also called diffraction. In the case of XRD, we use X-ray is a probe, X-ray to scatter from atom. In the case of TEM or high resolution TEM, we use electrons. Here we use electron as a probe. In the case of XRD, we use X-ray. There is a relation between the crystallite size and the grain size and the particle size. Sometimes the crystallite size should be equal to the grain size, but usually it is less than the grain size. And similarly, they are related to the particle size. Sometimes people mention a report the particle size value, and sometimes people mention the grain size value. Sometimes people mention the crystallite size. Why we need to compare this? Okay, let me show you quickly this sentence here. Look here. If we calculate the crystallite size from XRD, and if it is equal to the particle size or the grain size from TEM, this means simply that our material is single crystalline. So there is a relationship. You see here, our material is single crystalline. Okay, let me show you here quickly. We usually find the crystallite size from this d by Scherrer formula. This K and lambda is known here, theta is also known. We just need to find this beta, and this basically the full width at half maximum. And it is we easily calculate from, we just take any intensity here, you can see here, and this is the maximum intensity here, this we know the maximum intensity, and this is the half intensity, and we have to find this place. This is basically called the full width at half maximum. You see here, this is the maximum intensity, so this is the half, and we have to measure this here, this angle here. Very simple, we have to measure this angle here. You see here, this angle, and this is very small value here, you see, and it should be in radian. And if you don't know how to find this full width, this is the formula you see here. Just you take any peak here, and you can zoom it like this. I just take this, you see here, you zoom it from here. It is very, this with this help of this Origin software, right? Now let me show you here the grain here. This is the high resolution transmission electron microscopy images here. You see here, you can easily find the grain size from here, easily calculate, right? You can call it particle by I don't have any problem, right? If these are basically, if these two are equal, so you can also, this is basically the 2 nanometer bar here. So you just take this bar here, this bar, and just look here. If we consider this grain here, this grain, so 2 nanometer. Yeah, this grain look like somehow 20 nanometer in size, and you can call it particle, right? So if this size is equal to the crystallite size, so this means that we have a single crystalline material, but this is the polycrystalline material. Similarly, you can see here so many grains here. You see here so many grains here. But let me show you here the single crystalline material. You see, this is basically the single crystalline material. So here are no grains basically. You see, this is a single crystal. So where is grain? No grain here. No grain here. Here is only one grain. You can call one grain, or you can call one crystallite a crystallite. This means this is a single crystal. Single crystal. So if this value here, if we see here, this is 2 nanometer, and if you look here, this is very big single crystal. So if the size, calculated size of this TEM is equal to the XRD value per crystallite size, this means that our material is a single crystal, right? This is how we basically compare the crystallite size in the grain size by using two different methods.